So yellow is 4. 10 to the power 4 is the multiplier. Okay. And the fourth band is for the tolerance. Okay. So in the manufacturing process, there are some कुछ गड़बड़ हो सकती हैं जिसकी वजह से इसमें टॉलरेंस आता है. ठीक है. So उसके लिए for that here is some color coding. Okay. If it is some brownish, it's 1%. If it is red, then is 2%. And if it's silver, if it is golden, then 5%. If it is silver, then it's 10%. Okay. So you find the value from these three bands. Okay. And the tolerance from the fourth. Okay, guys. And same for the 5 band. Okay. First 3 band will tell you the digits, and the fourth band will tell you the multiplier, and the fifth band will tell you the tolerance. Same with the 6th band. Starting 3 will tell you the the digits, and the fourth one will tell you the tolerance, and fourth one will tell you the multiplier. Okay. What is the multiplier? Okay. And the fifth one is for tolerance, and the sixth one is for the temperature coefficient. Okay. So temperature coefficient is very important. If you put in microwave. Okay. Where is if you add in the furnace. Okay. The electrical furnace, their temperature is very huge. Okay. So the value will be increase or decrease, and there will be so much tolerance. The resistor might be damaged. This is the basic component, and it has the two legs. One is this. So here is the capacitor. Okay. So capacitor is basically the device that which store the electrical energy in the form of electric field. Okay. So the unit of the capacitor is capacitor, like farad, and there is some voltage rating also. And as you know, you can see, this is a non-polar capacitor. Here is no polarity, as you guys know. In the resistor, there is no polarity. In the capacitor, there are some different type of capacitor. In this one, here is polarity. This is called polar capacitor, and this one is non-polar capacitor. This one also non-polar, and this one also non-polar. Okay, this is a polar cone capacitor. So where is you can see white line is here, which is the negative part of this capacitor, and the other one is positive. And if you buy a new one, then one leg is short and one leg is long. Okay, so the long leg is positive and the short leg is negative. Okay, so here is some written values, as you can read, 1000 microfarad and 50 volt. Okay, so if you apply 100 volt, then it might be get damaged. Okay, so you have to apply under 50 volt. Okay, and it can store energy 100 microfarad. Okay, so here is some non-polar capacitor, and as you can read here the value 104. Okay, so 103 is the capacitance 10 nanofarad. Okay, and 104 is 100 nanofarad. Okay, so this is 10 to the power 14 times. Okay, here is some SMD components. Okay, and the comparison of with the matchsticks, as you can see, so tiny. These are the SMD one, and these are the non-normal capacitor. Here is some inductors, which is basically in a internal core. This is the core, and here is some copper winding. Okay, so it store the electrical energy in the magnetic field form. Okay, so the unit is Henry, and the maximum energy it can store, you can find with the formulas we have studied in class 12, and it is frequency dependent. Okay, so the capacitor is also frequency dependent. So when you apply AC current, Then there is some if you increase the frequency, then this voltage will down, and there are some factors. Okay, you will read study in EEC about it. Here is the inductor. Okay, so next come the diodes. So diodes are the basically like PN junctions. Okay, the P type semiconductor and N type semiconductor we just put beside and add it, and then become the diode. Okay, so diode is basic thing, like it can like control the flow of current. Okay, like if you add in like P N. Okay, so one side is P and other side is negative N. Okay, so if you connect the power supply in the positive terminal to the P type and the negative terminal to the N type, then current will flow. Okay, if you connect in reverse bias, then current will not flow. Okay, so as you can know, like if you had a LED and you can connect in a manner, then LED will glow, and if you connect in another manner, like reverse the polarity, then LED will not glow. Okay, so here different types of diodes, like pin diode, step recovery diode, Zener diode, Schottky diode. So so many types of LED is also a light emitting diode, so it's a different type of diode which emits the light. Okay, so these are used in rectifiers and regulators and power circuits. And like when you study in EEC, there will be teach you like some voltage graphs, like cutoff voltage, knee voltage, so many things. In the ESTC lab, you don't need to study about it because it's not in the syllabus right now. Okay, so the major thing is comes like the breadboard. Okay, so as you can see, the breadboard is called breadboard because it has holes like a bread. Okay, so when you buy a new bread and you see like there is so many holes, and here is also so many holes. Okay, so this side is the power line. Okay, and this side is also a power line. Okay, you connect the power line here and here or here in this rails. Okay, the both side, and the circuit you made like in between this, in this region. Okay, so if you connect the positive one here and negative one here, then power like voltage will come up to this point तक. Okay, यहाँ तक पावर आएगा और उसके बाद नहीं आएगा आगे. ये फुल साइज ब्रेडबोर्ड है, इसमें आगे नहीं जाता है. ठीक है, तो तुम्हें क्या करना पड़ेगा, यहाँ से वोल्टेज हमें जंप कराना पड़ता है. यहाँ पे वायर डालो, एक वायर यहाँ कर कनेक्ट here a wire and jump to this wire port. Okay, then the voltage current will flow from here to here. Okay, and similar for the ground. If
Hello,
you
sir. I have a doubt.
Yeah.
Actually, what is the use of this breadboard?
Okay, so let me tell you, like when you start the building a circuit, okay, you have some idea, like I want to make an amplifier. Okay, so if you use like components, I take this transistor and I take this resistor and this capacitor and this power supply. If you build a permanent circuit, okay, then you have to de-shoulder and shoulder and connect. You have to do like so much work. Okay, in the breadboard, you have to just insert the legs of components and like take out the component from the breadboard. You don't have to solder. Okay, it's very convenient to use breadboard. Okay, so like
Okay, it will make connection part easy.
yeah, just go here. You can see. Okay, if you have to just insert the resistor or anything which you want, just take it out. Okay, it's very simple. In the permanent circuit, you have to like shoulder and de-shoulder, so it's really hard. Okay, to do. It's basically used for reusability of components and breadboard. Okay, you can reuse
What
your
if we
components.
have many connections? Like, will this size valid for all connections, or should
Okay,
we increase our
listen.
size of breadboard?
Yeah, yeah.
if more
Yeah,
connections are there.
listen. If you have another breadboard, you can connect here. You can see the some part like this edge
Yes.
here. Yes, you take another breadboard and you can just like connect the breadboard. Okay.
Okay.
So I have two breadboards. Let me show you. As you can see. So as you can see, here is the breadboard, and here are some like pointy things. Okay.
Yes.
Here is some holes. Okay. Just snap it like this. Okay.
Okay, sir.
So you can add so many breadboards. You had you can.
Is there any count for this? One breadboard can make this many connections.
I will tell you the connections part and wait for it. Okay.
Okay.
So as you can see, like if you connect the power supply here, like here is this reason, and let me tell you the PPT. Okay. So if you connect the power supply like 5 volt here and ground here, okay. So the power will come up to this. Okay. Then you have to jump from here to here. Okay. Like shorting the using some wires, because if you have to make a circuit, like if you want to make a circuit like use in this region 5 volt and this region 3 volt, then you can connect 3 volt here and 5 volt here, and then you can use it. If you want to completely 5 volt, then short from here to here and here to here by using some wires like some wires like these jumper wires. Okay, got it.
Yes.
Okay, so this part is completely isolated. Okay, let me show you one thing. Yeah, so can you see? No, this one is like a smaller one. Yeah, this one. Actually, this is Windows 7, so I don't know how to zoom.
You can right click and save, and you can show that image.
Yeah, save. Wait a second. Wait a second. Controls. So, so here you can see like the rails are. Okay, so as you can see, if you connect the power supply from here, okay, then the power supply will come only up to this. Okay, then you have to short from here to here and here here to here. Okay,
Why, sir?
got it? Why? Like, so if you have to use 5 volt in this region and 3.3 volt or 3 volt in this region, then you connect 3 volt here and 5 volt here. Okay,
Okay.
you can buy connected ones also. So these one are not connected. Okay,
Okay, but that short part I didn't understood before you said.
no, you have to do externally. If you buy internally short, you can buy, or if you had if you buy externally, if you buy not shorted, then you can short externally. I will tell you. So 1, 2, 3, and 4 and 5. Okay, then the connection is will be break from internally. Then you have to insert this jumper wire. Okay, and then
Actually, that breadboard is blurred.
oh, can you see? Wait a second. Wait a second. It is joining from my phone. So wait a second. Yeah, okay.
Your microphone is off.
Oh, sorry. Sorry. Okay, so so if you connect the power supply, sound is echoing. If you connect the power supply here side, and here is the ground. Okay, then power will come like 1, 2, 3, and 4 and 5, up to 5 blocks. Okay,
Okay. Total there are 10.
yeah, total are 10.
Okay.
Okay, so you have to jump like this, so that your power, if you connect the power 5 volt here, then you have to jump from here to here, so that power 5 volt come up to here, up to here. Okay,
Okay.
and take another jumper wire which will be provided you in the lab session, like this box, and short the ground also, or you can use these type wires also. Okay, just uh, cut it and strip the outer part, plastic part, and just insert it. Okay,
Okay.
so this part is isolated and this part is also isolated. Okay, as you can see in this picture,
What is meaning of isolated here?
I will tell you. Okay, my screen is visible.
Yes.
So if you connect the power supply here, and if you jump these two connections, and then power
Uh,
supply will do this, and this is the power line. Okay, and this is the power line. Okay, this is the power line. Okay, and this is the power line. If you connect the power supply, the voltage will come up to this and come up to this. Okay,
yes.
for the middle part, for middle part, okay, for middle part, here you can see the middle part will this part and this part. Okay, which is connected in column wise, or here is row wise. Okay, the column is this one and this one, and the row is this one and this one. Okay, so let me show you this one. So if you connect the power supply will come up to this. If you short here, and if you connect the power supply here, then short here. If you want to connect the power supply here, if you want to use power supply here also by connecting only here, then just okay. So if you connect the power supply here, jump here and connect from here to here. Okay, the positive one to the positive line and the ground one to the ground one by using jumper wire. Then power supply will come up to here, and then here you also have to short these two part, and then power supply will come up to here, and you can use everywhere. Okay, so if you have made like a circuit like this one. Okay, or like if you connect the power supply here, then power supply will come up to here. Okay, so if you connect the resistor, okay, so the middle part, like these five dots are connected internally. Okay, and these five are connected internally, these five are connected internally, but these three dots are not connected internally. Okay, 1 2 3 4 5, 1 2 3 4 5, these are connected internally, these are connected internally, but these two are not connected internally. So if you connect something here, then it will come up to here, not here, or not here. Okay, got it?
Yes.
Yes.
Okay, so if you connect the power supply here and jump from here to here, then this resistance has the power supply, the resistance has the power supply, but in the next column and the previous column doesn't have the power supply. Only this column, these five dots have the power supply. Okay, and
Okay.
as it, and similarly here is like five dots are connected internally, here five dots are connected internally. Okay, and these two dots are not connected internally. मतलब ये जो लाइन है, ठीक है, और ये जो लाइन है, ये आपस में कनेक्टेड है, बट ये दोनों आपस में कनेक्ट नहीं होते हैं. ठीक है, जैसे कि ये रेजिस्टेंस, like these resistance are connected with these resistance. Okay, so I jump
If we
like
want to add points, can we connect vertically other breadboard?
vertically.
Means all are same, na? 1, 2, 3, 4, 5. They are same now. If we want more than that, which is more than this capacity,
Yes, yes,
how can we?
yes. You can connect those. Look, in this breadboard, it doesn't have, but if I had one which has the connecting similar like which I showed you. Okay, you can extend the breadboard by just
Vertically
connecting
also.
like yeah, vertically also.
Okay.
These are simulation ones. Okay. So
Means if we connect another breadboard, then will they be same, or we should connect another wire which is connecting this both?
okay, so breadboard are made same, but if you want to give the power supply to the next board, then you have to short these boards by using external wires from your side. Okay,
What
Okay.
is meaning of shorting that?
shorting.
Means
Okay, so like this, I give the power to this rail. Okay, these 5 rails, and the ground to this 5 rail, and I short this rail to this rail. Okay, this is the sorting. If you connect take a wire and connect it to 2 rails, then those 2 rails are shorted. Okay, like here you can see ground is shorted to this resistance. Okay,
no, sir. What is general meaning shorting? Short
okay,
means it will connect, or what will happen?
short is like connecting one point to the another point. Okay,
Okay.
you have 2 terminals,
Now I
you can
understood.
connect using a wire, you can connect those 2 points, and this is the meaning of sort. Just connect to points, terminals.
Okay.
So this rail is connected completely internally, and this is not connected. Okay, so if you give the power supply to the here is no power supply, or here is no power supply, only this rail has power supply. And after that the resistance are in the parallel. Okay, okay, so this is the short and this is the short. Okay, so these resistance are in the parallel. Okay,
Yes.
let me know. Can you see the whiteboard? Yeah, awesome.
Um, Sorry for interrupting. I think that showing an example would be much easier to understand how a breadboard works.
Okay, so let me tell you the parallel and the series, and then I will show you how to connect on the board. Okay, so this is a resistance. Okay, and here is the different resistance. We draw like this. Okay, in the breadboard there are uh, columns like these which are connected internally, and you just take the resistance are like these, which has 2 terminals, and just insert this terminal to the this point and this terminal to the this point, then it will be connected. Okay, and if you have to connect in parallel, then just add another resistance in the same rail. Okay, in the same rail, in the same column. Okay, if you have to connect in series, then like
Beside
this,
side.
yeah, this is the one column, and here is another column. Then just put the resistance like this. I'm drawing from mouse, so sorry. Okay. Okay. So these two resistance and this resistance are in the series, but these two resistance are in parallel. Okay.
Yes.
You can connect power supply here. Okay, like this. If we draw, and connect it to the ground. Okay, so these are basic circuit which you can think, and I will show you how to connect in the breadboard. Okay. Let me join from the board. Can you hear me? Hello. Am I audible?
Yes, yes.
Okay. So can you see my breadboard?
Yes.
Okay. So I have a bunch of resistors here. You will get like these resistors in the ESTC lab. This box. Okay. Let me take the resistor from here.
Can you increase your volume?
I एक हाथ है. Right. Now it's clear, right? Maybe sound
Yeah.
is, yeah. Right. So like this rail is connected. Okay. And this rail is connected. Okay. I will insert my resistance one leg here and another one here. Okay. And I take another resistance. I will insert it. Yes, Bhaiya. Pankaj Bhaiya, are you saying something? So I will short these things like this. Okay. So you guys. So this rail is connected and this rail is connected. Okay, so I just inserted resistance here and here and here and here. It's really hard to manage these things. Okay.
Oh,
If you want to connect in series, then take these resistors and insert it right here and here. Okay,
Okay.
you have to connect in the same rail, then it will be shorted, and then it will be in series. Okay, as I showed here, you have to connect in same rail, and you can see. Okay, if you want to connect the power supply, if the power supply is coming, then just insert these jumper wires, and if you want to use like this white wire is power 5 volt, and this black wire is like ground. Okay, so if you have to connect the 5 volt and ground across these series connections, okay, so just take 5 volt. Ouch. And insert it in this rail, and take ground from 1 2 3 4 5 from here to connect here. Okay, so these resistors are now connected across 5 volt and ground. If I connect this to the 5 volt and ground, then this is connected. Okay, if you add any doubt, you can ask, then we can move forward. No doubt. Okay, so let me present. Okay, so I just connected 5 volt here, and across like in this rail. Okay, so I connected power supply in this rail and ground in this rail. I just connected 5 volt to the this shorted and this rail, and I inserted the resistance in this rail and this resistance in this rail, and another lug of resistor I inserted in this rail, and I just shorted with the ground. Okay, and here is a mistake in this photo. I took this from internet. So actually this is right. Actually, can you tell me how? Anyone?
Probes are too big to be fitted into breadboard holes.
Yeah, but it's connected here and here, which is like nonsense. Okay, because these 5 rails and these 5 rails are not connected internally. They are independent. Like these connections are and these connections are independent. So we made circuit in this side, and we are measuring voltage in this side, and it showed 0 and 0. This is the current, but you have, if you want to measure, then you have to connect positive one here and negative one here, then you can measure the voltage across these circuit. Okay, okay,
Okay.
so breadboard is clear. Can I move forward?
Yeah. Yeah, it's clear.
Okay, let me show again this photo so that you can clear more. So as you can see, like here, this is the column and this is the row. These are connected only 5 points and 5 points. These are not connected internally, and this is not connected internally. Okay, remember this photo. So let's move to the LM1000 first, then we will come to the LPF and HPF and band pass also. So when you go to the lab, they will hand you this kit. Okay, this is the LM1000 kit box, which I had also, and inside the box you have a USB cable, which is used to connect your laptop to this kit, and some jumper wires. Okay, this is the kit, and this is the USB. So let me tell you some connection points in this kit. Okay, so here is the USB connection, and you have to plug the USB B point here, and just add the USB A part to the your laptop, and run the Pixel Pulse 2. I will tell you how to install and how to run it. Okay. So you have to connect the USB port here, and then you can see here is some points to the input and output pins, and here is some points for the input and output pins. Okay, so as you can read here, what is written here? This point. Hello.
Channel A.
Okay, so this is the point channel A, and this is the point for 2.5 volt, and this is the GND, matlab ground. This is the ground point. Okay, and here is some 5 volt, and here is channel B. So channel A is like output point or input point. Okay, let me tell you more about it. So here is 2.5 volt. If you power by USB, then 2.5 volt will be here, and ground is the like reference point, and it has 0 voltage. Okay, and another ground point use your circuit, and here is 5 volt. If you just power the Adler 1000, then 2.5 volt and 5 volt will come here, and ground will be here. Okay, and if you want to give any wave, actually this is the analog device. Okay, so analog device, what is analog? Analog is like not from apart from the 0 and 1. Okay, if you talk about in Arduino and programming, then it will be show like 0 to 255. Okay, in between any number which will represent a certain value of voltage, it will be an analog. Okay, so here like let me tell you more about it from here. Okay, so this is the Pixel Pulse 2 software. Okay, the Pixel Pulse 2 software UI. Okay, so you can see play pause here, and setting button here, and channel A, and voltage and current. Okay, so you have to select the wave from here, and select, like I have selected the sine wave, and as you can look here, here is something 500 hertz, I guess. No, 1000 hertz. Here is the frequency. Okay, you have to set the frequency. Just tap here and write the frequency, and if you want to set a voltage, tap here and set the voltage. Okay, and here is another voltage, like peak to peak and RMS value you have to set if you want to. So I selected the sine wave, and I set the 1000 hertz and 2.5 volt, and just run from here. I click here, the wave will run, and I have selected the channel A. Okay, so in my channel A, in Adlam 1000, here I will receive this wave. Okay, the sine wave in the voltage format. Okay.
Yeah.
And if I select here in channel B the voltage or current, and I set the wave also, like I set triangular wave, then it will send triangular wave to channel B. Okay.
Can I ask a
So
doubt, from where will we get the sine wave? Like, first we have to connect a voltage 2.5 and then we have to connect it to channel 8 to get the sine wave
no, no.
corresponding.
Okay. So you download the Pixel Bus 2 and connect the Adlam 1000, and then open the UI, like open the Pixel Bus 2 and select the wave, like sine wave, triangular wave, or square wave, and set the frequency and voltage. When you set the voltage like 2.5 volt or 5 volt, then the sine wave will go like 0 to 5 volt. Okay, it will be the like amplitude of the wave. Okay, and it will receive at the channel A. Okay, here. Got it?
Okay, okay. Okay.
If you want to use 2.5 volt in a circuit, just connect a jumper wire here and use it. Okay, so these are the like fixed value voltages and ground. You just insert jumper wire and use it in your circuit. If you want to like use waves and read the wave, then use channel A, channel B. Okay.
Okay, sir. Thank you.
So here is like you select the wave and just play the wave, and it will be go through, and you will receive at the channel A. If you want to like just want to read channel A, what is coming at channel A, so just short channel A to channel B. Okay, if you want to read like what is coming at channel A, just you open the Pixel Bus 2 and set the voltage like wave like square wave at 100 hertz and 5 volt. Then if you want to read it, then just connect a jumper wire here to here. Okay, then you will play the wave, then square wave will be here. You can see the will be able to see the square wave at 5 volt, and the channel B, which is receiving the wave, it will like work like a oscilloscope. Okay, so this is the Adlam 1000, which is both thing, like it is oscilloscope as well as function generator. Okay, so function generator is like generate waves, okay, at different values and different frequencies, and oscilloscope is read the frequencies and read the wave. Okay, so it will work both. Okay, so you just play square wave here at channel A and short channel A to channel B, then you will receive like you can read the channel A using channel B, and it will be displayed here like a square wave. So this is like a different picture which I had. Actually, this is not my laptop. Okay, so this is a very old laptop, so I cannot run right now at Pixel Bus 2. Okay, and the professor will tell you how to use it, but I'm telling go in advance. Okay, so you select the wave and set the frequency and voltage. It will be run at channel A. If you want to read it, then use channel B. Okay.
Okay, sir.
And if you want to use like some dot intensity, like the brightness and other things, you can go to setting and appearance, and you can change things from there. If you want to give at channel A, channel B, both like send a wave. If you want to send a wave like a square wave at channel A and a triangular wave at channel B, then you can select here the wave and here the frequency and the voltage, and here is the wave and frequency and the voltage. Just hit here and then run. Channel A, you will receive square wave, and at channel B you can receive a triangular wave, as you said. Okay, and in this side here is some more pins to interface. Okay, so A in. Okay, so A in is also a input pin. Okay, so if you connect something, like if you build a circuit and you want to read the voltages and different things, you just connect here and connect in the circuit, then you can read it directly. Okay, the channel A, same thing, 2.5 volt, same thing, ground 5 volt. Actually this is the bigger version of board. Okay, and this is a D version and this is a F version, so it has some more features. So as you can see, I have one. So we have this type of F version of board. Okay, and here is some more pins. These are called input output pin, IO pin. Okay, so you can connect and run and read the different values. But in this ESTC lab, you have to use only these pins. I mean these pins. Okay. If you had any doubt in Pixel Burst or Headlamp 1000, you can type.
Sir, you are not audible.
Sorry. So if you have any doubt now, then you can ask me in the Pixel Burst or Headlamp 1000.
Sir, could you please explain the concept of pins A and E
Your
and B
voice
and
is very low, so I can't hear. Hello. A in and AB. So these are the input and output pin. Say like input pin. Okay. If you want to use it, you can connect and use it in. But you don't have to use in this ESTC. Okay. You have to just use channel A, channel B to read, and CHA A and CH3 and ground in the pipe. I will tell you brief in LPF and HPF. Okay. Mode outs.
Sir, I already completed my ESTC and EEC also, but I am not well versed with the scopes of ADALM, and I would like to know more. So, what are the future, or what are other uses of ADLM we can use, or what is actually the potential of ADLM that we have right now?
Okay, so if you jump in the electronics, and if you go in microprocessing and processing unit, and then one thing is very fundamental thing. Okay, if you want to run any IC, then you have to give some clock signal. Okay, you have to give it, otherwise your circuit will not work. Okay, everything work on clock signal in the electronics.
Sorry, sir, block signal.
Clock signal, clock. CL. Okay.
Okay.
Yeah.
Hello, Harivam. Subhash this side.
Oh, okay.
So yeah, myself Subhash. I'm one of the PS for ESTC lab. Uh, if there's time, I would like to add upon something for what she asked.
Yeah, of course.
Yeah, see, our ADLM kit which we have, it had a lot of functionality in it. Basically, what we are using right now for both ESTC and EC labs is like 5 to 10% of what it can actually do. If you are familiar with the actual oscilloscopes, there's actually whatever we can do with the oscilloscope, we can do with our ADLM kit. We can generate the like there are some this may sound like some jargons for you, but since you have completed your EEC course, so you can even make out the Bode plots of the circuits and all, and also you can program your own outputs as you wish. You can make your own pixel pulse once again if you are really interested.
Yeah, I've heard about this, oscilloscopes, and it, we can it works somewhat similar to oscilloscopes in a
Yeah, not
different.
somewhat similar. Actually, even I came to know about this very recently, and I have been experimenting. It's similar to the traditional oscilloscopes. Only disadvantage is it cannot read the negative voltages.
Okay, let me tell you. Like the oscilloscope is basic thing like oscillator. Okay, so oscilloscope is like you have to give a signal. Okay, in a circuit. So you just set some waves. Okay, like I want to use sine wave, and then this voltage and this frequency. You have to set it, and you can use it, and you can understand the behavior by seeing it using. Oh, sorry. I confused it. Okay, so if you want to generate a wave, then you have to function generator, and if you want to read any signal which is coming from anything, like if you had an antenna, you can connect to the oscilloscope, and then you can read the signal which is coming from the radio antenna. Okay, and you can trim it, and you can in ESTC they taught us like use of antennas and different things. So if you want to read this, just add it to the ADLAB 1000 and read it at channel B. Okay, so these are the very powerful things in electronics. These are the very fundamental things to use, and I made it by using which is called Arduino, a function generator and oscilloscope. I made both using that, uh, which actually it has processing like frequency was 16 megahertz. So it can generate like 100 hertz sine wave, and I guess 77 hertz. No. 100 hertz square wave and 77 hertz sine wave, and triangular wave was 90 hertz. Okay, by using Arduino, which is like price at 400. Okay, so if you want to use it, you can understand the behavior of any circuit. Okay, uh, if you buy a transformer, okay, you give AC signal to this, and it will step down it, and it will provide you. Then you use which is called what rectifier. Okay, by using 4 diode, we made full bridge rectifier, and like हम जब like वो यूज करते हैं, क्या बोलते हैं यार, फुल ब्रिज रेक्टिफायर यूज करते हैं. ठीक है, तो उससे पहले अगर हमें रीड करना है तो ऑसिलोस्कोप आप कनेक्ट कीजिए, आपको वोल्टेज का सारा ग्राफ मिल जाएगा. ठीक है, कि हमारा वोल्टेज कैसे आ रहा है. ठीक है, अगर आपने लाइक आईसी यूज किया, आईसी में अगर आपको क्लॉक सिग्नल देना पड़ेगा तभी हमारा आईसी अच्छे से काम करता है. ठीक है, आप कोई भी आईसी उठा के देख लो, उसमें आपको क्लॉक सिग्नल देना ही पड़ता है, तभी वो अच्छे से काम, क्योंकि वो फंडामेंटल चीज, ड्राइवर चीज है एक टाइप से. ठीक है, कि अगर आपने 010101 दिया एक सेकंड के अंतराल डिफरेंस पे, देन वो अपना कंपटीशन उस हिसाब से करेगा, और वो अगर हमें रीड करना है तो उसके लिए ऑसिलोस्कोप आता है, और हमें क्लॉक सिग्नल देना है तो उसके लिए फंक्शन जनरेटर आता है. ठीक है ना. ओके, इज इट ओके?
Yes.
Yes, thank you so much. Subhash bhai, to let's hurry.
So both things are very important in electronics. Okay, so the pricing of Adlam 1000 is 9,700 approx, and if you buy a separate oscilloscope, you can buy up to lakhs, and its starting price is like 9,000, I guess. And if you want to buy function generator, you can buy like 14K to up to lakhs. Okay, and this is a very powerful thing which has both things at price of 9,000. Okay, so let me continue this. So this is a pixel burst software which I told you. and you can generate waves and different things. This is the ADLM 1000. So let's come to the low pass filter. Okay, so the low pass filter is basic thing. Okay, okay, you put like okay. So first of all, you have to understand that capacitor like changes its behavior when we apply like AC signal. Okay, so that is why it is used in rectifier to filter the voltage. Okay, um, so explain कौन से करते हैं? So if you want to use a capacitor, so okay, let me tell you. So this this is our basic graph. Okay, so bad. Okay, so this is the frequency one, and here is the voltage. Okay, I mean this is the time. Okay, time. Okay, so when we put wait a second, let me clear this. Okay, so this is time and this is the voltage. Okay, so if you add a sine wave to the to a capacitor, okay, so you put a sine wave to the capacitor. Okay, it will change the polarity, and this is the positive side and this is the negative side. And now let me use different color. So if you filter it out by using like half wave rectifier or full wave rectifier, if you use half wave rectifier, then wave will be like this. Okay, if you use full wave rectifier, the wave will be like this. Okay, or when we use like capacitor in our filter, then okay, so capacitor store the energy in the electrical form. So when voltage will increase, the capacitor will be charged. Okay, then voltage will decrease, the electrical energy will give the power to the circuit. Okay, provide the voltage, so it will resist the change. So when it drops, it will try to continue. Okay, it will drop little bit but not that much. And when again the voltage start, I'm telling about the full wave. Okay, about the green graph. So when voltage charge, then capacitor voltage will charge, and when it will decrease slightly, but the voltage increase again, then it will charge again, and drops, it will continue, and then again it will charge, and then drops, then again it will charge, then again it will little bit drop, not that much. Okay, so this is the output voltage. You can see how much it is filtered. Okay, if you zoom out, if you use a correct value of capacitor, then it will be completely straight. Okay, if you use multiple filters, then it will be completely straight. No voltage variance, like voltage difference so much. Okay, so this is the use of capacitor. It happens in the frequency. Okay, if you increase the wave time so much that capacitor charge completely drain out, then it will decrease so much. Okay, and then it will charge. So it depends upon what is your frequency. So capacitor is frequency dependent thing, and inductor is also. So when you change the frequency, the capacitor energy will decrease, increase, decrease, and increase, and according to the time limit, it will like completely vanish or little bit vanish, and this thing happens. So resistor is not dependent on frequency, and capacitor and inductor is dependent on frequency. Okay. So in low pass filter, we use things like give me one second. So when we put AC wave here, like we made a circuit, like adding a resistor and connect a series with the capacitor, okay, and ground it, and when we put voltage, AC voltage across this and this terminal, okay, when we increase the frequency, then voltage will be dropped, okay, and we will read across the capacitors, ठीक है. अपना आउटपुट वोल्टेज हमारा कैपेसिटर के अक्रॉस आएगा और हमने एसी वोल्टेज देंगे, ठीक है. जब एसी वोल्टेज देंगे, हमने 5 वोल्ट सेट कर दिया, बट फ्रीक्वेंसी हम लोग चेंज करेंगे, ठीक है. फ्रीक्वेंसी इंक्रीज और डिक्रीज करेंगे, तो उसका बिहेवियर है कैपेसिटर के अक्रॉस वोल्टेज का, वो हम लोग रीड करेंगे बाय यूजिंग एडला 1000. ओके. ओके.
Yeah, okay.
So we will put the AC signal here, and when we change the frequency, the voltage will change, and here is the cutoff voltage, cutoff frequency 1 by 2 pi RC. So R is the resistance value and C is the capacitance value. Okay, you have to use non-polar capacitor here, and as you know, like 103 is 10 nanofarad and 104 I guess 100 nanofarad, I guess. Yeah, that's okay. You can calculate by using Venkata bhaiya. So, I think he's not here. Okay, so I think 10 in non-polar capacitor, if it is 103, it's 10 nanofarad, and if it is, as you can see here is 104, that means 100 nanofarad. If it is 103, then it's 10 nanofarad. Boom. Okay, we put in sine wave and read across the capacitor voltage, and we will find the cutoff voltage. Okay. In EEC, you will study about J omega, like capacitor is like written in terms of omega, and so many things. Okay, it's called impedance and resonance frequency and so many things. Okay, so when we increase the frequency, our voltage will drop. Okay, and I guess the cutoff voltage is called like V input by root 2. Okay, you have to calculate it. Okay, and when we increase the frequency, the voltage will drop. When it comes across like 70% of the initial voltage, this is called a cutoff frequency, and you have to find like in starting, you have to start with the 10 hertz, then 100 hertz, then 200 hertz, and 300 hertz, and read the voltage across these, and write in the Excel. In that lab, you have to write in the Excel, and you have to draw a graph of it. Okay, and the graph will be similar like this. Okay, and this is the low pass filter. Basically, I will tell you how to connect in the with the ADLM 1000 in the breadboard, and this is the gain. Okay, I don't think it's need in right here, but you have to learn about it. Okay. So this is used for like filter out the frequency, like filter out the voltage. If voltage like when we increase the frequency up to this certain, we have to filter like we don't need the voltage. Okay, so this is used in this. Okay, here is a high pass filter. Similarly, we have to connect capacitor and resistor in series and apply AC voltage and read across the resistance voltage, which is the output voltage. And here is the cutoff frequency of 1 by 2 pi RC. Okay. So look closely here. Okay. इधर कैसे connect होएगा? So here is a graph of frequency versus amplitude, like output voltage, and this is the low pass filter and this is the high pass filter. Okay, so for the same value of capacitor and resistor, you have to find the same value cutoff frequency. Okay, for both the circuits. Okay, I will tell you brief about it. Okay, so when we decrease the frequency, and you will find a certain value of frequency where the voltage is remains only 70% of the original voltage, and when you read across the resistance, I mean high pass filter, you increase the frequency, you will look for like 70% of the initial voltage, and that will be the cutoff frequency, and you have to match both the voltage like graph. Okay, you have to intersect both the graphs at the cutoff frequency. Okay, this is the cutoff frequency, and the cutoff voltage is 6.6. Okay, any doubt? I will tell you a brief. If you had any doubt right now, you can ask. कोई डाउट नहीं है? ठीक है. Let's move forward. So now I will join from my phone, and I will tell you how to connect LM1000 in the high pass filter and low pass filter. Okay? आना कुछ तो बोले यार. So let me join from my phone. Hello. So, as you can see here, okay, this Adla 1000. Let's set up this thing anywhere. There is the USB cable. Okay, you have to connect this thing uh, right here and connect this part to your computer. Okay, I'm leaving that. And so first you need to take one resistance, and if you want to select a resistance, you have to do some calculations in the starting. Okay, so let me erase these things, then I will tell you something. Oh, next slide आ सकता है यार. Okay, so like this is our resistance, and here is our capacitor. Okay, and I connected it to the oh, sorry. Uh, okay, this is the symbol of AC source, which I will provide from the ADLAM 1000. Okay, and this part is positive right now, this part is negative. After some time the polarity will change because this is the AC source. Okay, so if this value is R and this is C, okay, so if you want to give some frequency, then you have to select the wave sign, and for now you have to select the sine wave, and you can give a frequency by CHA. Okay, you have to connect CHA here and the ground right here. Okay, and for CHB you have to connect here so that you can read the voltage from across the resistance, क्योंकि this देखो ये हमारा कनेक्ट है ग्राउंड से, ठीक है, तो यहाँ पे हमने CHB कनेक्ट करा दिया है एडलम 1000 का. CHB हमने कनेक्ट करा दिया है, CHA से हम लोग इनपुट दे रहे हैं, ठीक है ना, CHA से हम लोग इनपुट दे रहे हैं, ठीक है, और ग्राउंड हमने कनेक्ट करा दिया, तो इसके अक्रॉस वोल्टेज हम रीड कर सकते हैं CHB का यूज करते हुए, और वेव हम लोग जो देना चाहते हैं वो हम लोग CHA का यूज करके दे सकते हैं, ठीक है ना. So we will use both the channels. For now we will give input by using CHA and read by using CHP. Okay, so the cutoff frequency, I mean the F, is you can find from 1 by 2 pi RC, 2 pi RC. Okay, so you have to select some good value so that you cannot stuck in these calculations. Okay, so I took resistance 1k ohm, 1k ohm, and the capacitor I will use 10 nanofarad. So can you tell me what is the one cutoff frequency for it? Anyone? So you can calculate cutoff frequency for it. So I will show you the circuit, and so this is the one. This is not 1K resistance. This is a 330K resistance, but I am using it to show you because I'm not going to run this uh, circuit because I don't have that configuration laptop. Okay, so I will connect this resistance at this board. Okay, so I will take a capacitor, which is here, as you can see. Okay, this is a capacitor. Okay, and it has written like 103 then 10 nanofarad. Okay, so to connect it in series, you have to connect it like this. Okay, okay, so in the same rail you have to connect the capacitor, and other leg will go to the uh, after the middle part. Okay, okay, so the resistance, one leg resistance is here and the second leg is here, and the second first leg of the capacitor is goes into second leg of resistor. Okay, and the other leg of capacitor will go to the different side of breadboard so that it don't short. Okay, so now I will tell you guys how to connect it. So I will connect to the LM1000 to CHA by using jumper wire. I had connected and a ground. Okay, so it's connected. So we have to give across the resistor CHA. Okay, so I connected it right here across the register, and the ground I will connect across in the rail of capacitor. Okay, as you can see, and now I will read from CHB. So I need one more jumper wire. So I will connect it to the CHB. Okay, I had connected. I will connect to this node. Okay, in the same rail of resistor and capacitor. Okay, so I don't have any pen right now. So the CHA goes across the resistor and the resistor line, and in this line I have connected the CHB to read voltage across the capacitor, and I connected the ground to the across the capacitor. Okay, now you will connect this USB port to your laptop and run the Pixel Pulse 2 and read the voltages and give the wave, and it will show you and change the frequency and the voltages. It will show you the cutoff frequency, and you have to calculate all these things. Okay, so for the high pass filter you have to switch these things, like you have to read across the resistance voltage. Okay, so I will change a little bit these things. I will disconnect the CHA, CHB and ground. So for the high pass filter you have to connect like this. This is a AC source, sorry. We have to read across the resistor, and here is C and here is R. We have to read across this. Okay, and this is the AC source. So the cutoff frequency will be same 1 by 2 pi RC, and we will read across the resistance. So this is the CHB. CHB will go to the same node. Okay, the connection of resistance and capacitor, I mean this point is called node. Okay, and the CHA will connect to the across the capacitor to the capacitor, and the ground will connect it to the resistance. Okay, as you can see, so the ground is connected across the resistance, and the CHB where we read the node voltage across the resistance, I have connected here, and the CHA I have connected to this. Okay, across the capacitor, and then you have to run change the frequency and find the voltage and cutoff voltage. You can. Okay. If you had any doubt, you can ask, or I will come to the next topic, which is band pass. Hello. Yeah. Okay. So you search for the pixel pulse 2. Okay. Let me leave from here. So you have to search for like pixel pulse 2. Pixel pulse 2, and it will redirect to the this GitHub link, and you can go here. If when you reach to the lab session, they will provide you a video. Okay, how to download the pixel pulse to how to run AdLab 1000 in like ऊपर ऊपर से बताएंगे वो, ठीक है, इतना डेप्थ में नहीं बताएंगे, ठीक है ना. सो यहाँ से इधर से कहाँ से डाउनलोड करते हैं, मैं भूल गया. इधर नीचे होता था, हाँ नीचे, ठीक है. यहाँ से जाके यहाँ से डाउनलोड कर सकते हो, ठीक है. यहाँ से किसी भी मतलब लाइक OS X के लिए कर सकते हो, विंडोज के लिए कर सकते हो, लिनक्स के लिए कर सकते हो, बिल्ड कर सकते हो खुद से, ठीक है. और लाइक अगर मैं विंडोज के लिए जाऊँ, क्षितिज चेंज करते थे ना. हाँ यही करते थे ना. यहाँ से डाउनलोड करने के बाद में उसे आपको रन करना होगा. मैं रन नहीं करने वाला क्योंकि ये मेरा सिस्टम जो है बहुत पुराना है, ये चला जाएगा, ठीक है. यहाँ से डाउनलोड करके आप उसे रन करेंगे तो हो जाएगा, ठीक है. सो दिस इज द सेशन organized by Sahyog, a new club for teaching you guys and helping you guys, and you can help other students as well as by joining us. Okay, if you had any expertise in any subject, you can join us, and you can help them. Like you have any skill like web dev or anything, you can join us, and we will organize a session like this, and you can teach them, and we will run offline center also. Okay. So when we'll upload this video to the YouTube, and we will share the link in the general discussion or your community also. Is the AdLab kit is provided at the college, right? Okay. So AdLab kit, you have to buy AdLab kit. Okay. By paying 750 rupees. Sorry, 9,750 rupees. Okay, and they ship you, or when you reach to the college, and they will hand you, okay, the kit and the components. The price is 9,750, and for the component this is 1,714 rupees. Okay. If you had any doubt or any suggestion, हम बता सकते हो. किसे भेजूं? इस कमेंट सेक्शन भाई जब चला जाएगा क्या? इसी कॉपी करके भेज दो ना, ऐसे हो जाएगा ना. ये विंडोज 7 है. सो आप लोग अपना फीडबैक बता सकते हो और हमारा जो क्लब है सहयोग उसे भी ज्वाइन कर सकते हो और उसका जी फॉर्म हम लोग क्लब नीचे दे रहे हैं. ठीक है, उसे ज्वाइन कर सकते हो. क्षितिज अपने क्लब का जरा दे देना है. ठीक है, व्हाट्सएप नहीं, रजिस्ट्रेशन फॉर्म दे दो. PPT access denied. Where? Okay, I will share you PPT by downloading it. Okay, don't worry. We'll upload this video to the YouTube also. You can subscribe our channel and you can follow us on Insta and other platform also. And you can join us. Can you say what? Actually, let me tell you my experience. I reached at center. I reached the Chennai at the exam day, like lab day, and by 6 o'clock morning, and I get dressed and I go to the lab by 9 p.m. 9 a.m. and I did my lab. Okay, I attended the session, first session, introduction session, and then did my lab, and then I do break, eat the lunch, and I did second part of my lab. Okay, and I returned to the Marina Beach and come to the station. I slept there, and tomorrow my train. I came to the Kanpur back again. So मेरे से तो बस LPF HPF कराया गया था, बाकी मैंने सबकी मदद की थी लैब में, मेरे आगे पीछे सब जगह. हाँ भाई ये लो छापो, व्हाट्सएप पे मैं डेरिवेशन दे रहा था भाई, ये लो डेरिवेशन. सो
कितने सारे एक्सपेरिमेंट करने होंगे एसटीसी लैब के लिए? 2
करने होते हैं, LPF HPF, और शायद से बैंड पास भी कराएं. अगर 2 दिन का है तो बैंड पास भी कराते हैं. ठीक है, और क्या बोल सकते हैं?
Okay.
Could you please tell about Arduino projects? Okay, so I think I will organize a workshop also in October about Arduino. Okay, please join there. And I am from electronics. I am doing electronics since my second class. Okay, I made an amphibian car in 4th class, which run by air. Okay, so I will teach you guys. If you want, you can DM me or ask me any question if you had. I can give you the do we have submit a report with the okay? So you have they will provide a link. Okay, drive link. You have to like plot the graph. Okay, of LPF and HPF cutoff frequency and voltage. Okay, and take the screenshot of those and write the derivation and took the picture and drive it to the Google Drive link. They will provide you there. Okay, you have to join the G space and then you can visit your lab and then they will provide you approximate cost of
Don't tell us about band pass.
Band pass. Wait a second. I didn't added any slide for the band pass. So the band pass is basically the combination of these two circuits. Okay. So let me show you guys like band pass circuit graph. Okay, so here you can see Okay, when we increase the frequency, and the voltage will get drop and increase. Okay, you can see now.
Yes.
So when you increase the frequency, okay, and the voltage will this part is what is this part in the starting part? It is low pass filter or high pass filter?
Low pass filter.
Achieve. Is this low pass filter? वो चेक पढ़ लियो यार, ठीक है। तो स्टार्ट में हमारा लाइक हाई पास फिल्टर होता है, ठीक है। सेकंड में लो पास फिल्टर होता है, ठीक है। हम जब वोल्ट फ्रीक्वेंसी इंक्रीज करते हैं तो दोनों का जो लाइक कट ऑफ फ्रीक्वेंसी है, तो उसके बाद हमारा जो वोल्टेज है या फ्रीक्वेंसी है उसको इग्नोर करेगा, हमें केवल ये काम कराएगा। दिस इज द बैंड। ओके, सर्किट थोड़ा सिमिलर ही होता है पर थोड़ा सा चेंजेस होते हैं। I don't have any circuit right now, so I can show you. I can tell you. Band pass filter can be done by cascade, high pass filter and low pass. Yeah, वही तो बोल रहा हूँ यार। So, any more question? We'll organize. Do you know, guys, Tinkercad, Autodesk, or Walkme?
No, we don't know.
So then join our workshop on this. Okay, we'll tell you guys. And जो जिनको मेरे बारे में नहीं पता है, मेरा नाम हरिओम है, मैं डिप्लोमा में हूँ इस टाइम पे, और मैं कानपुर से, ठीक है, और इलेक्ट्रॉनिक्स में काफी टाइम से काम। Is it possible to turn reverse of the two filters? Yeah, I guess you can. Like, so if you increase the frequency, okay, take example, like if you're using a low pass filter, if you increase the frequency, okay, it will be like cut off frequency first and then it will shatter, okay, and then in the different manner, if you decrease the frequency, and you will cross the cut off frequency and cut off voltage, and then it will drop. Okay, so you can do, it doesn't matter. It's basically used like filtration. Okay, where to reach you for some after meetouts? I can type my mail and my WhatsApp number also. Can, but don't spam, guys. 24F0032 at es.study. So फीडबैक भी दे दो यार, मतलब कैसा लगा? This is my contact number and yeah. अभी बता देते हैं ना यार, ये लोग फॉर्म तो डाल ही देंगे। डाउट है तो बताओ, कुछ सजेशन है तो बताओ, कोई फीडबैक हो तो वो भी बताओ, हम तो सुनने के लिए बैठे। मजा आया? सो कोई डाउट, कोई सजेशन, कोई फीडबैक नहीं है? It's my time to leave. Yeah, you can. It's not chit chat time. It's working. Okay, no problem. So, if you had any doubt or suggestion or feedback, you can give. Okay, thank you. Any suggestion? How many experiments can be do at the lab? Okay, so you have to do low pass filter and high pass filter and band pass filter. If they say to do band pass filter, otherwise you can't. You don't need to. Okay, they will instruct you. No problem. They will very helpful. Okay, and some of our friends are TA there. If you can find them. And, so when you come to the diploma level, you can become TA also. Okay. कोई डाउट नहीं है, खत्म करे क्या? बढ़िया था गुरु, थैंक यू। सो कोई ऑर्डिनो के बारे में पूछा था, ऑर्डिनो वाला है अभी यहाँ पे, तो मैं थोड़ा बहुत बता देता हूँ, अगर हो तो थम्स अप करो भाई। कोई भी डाउट हो इलेक्ट्रॉनिक्स से रिलेटेड पूछ लो, फ्री बैठा हूँ मैं। अंकित भाई तुम पूछ रहे थे ऑर्डिनो के बारे में, थम्स अप करो अगर पूछ रहे थे। The lab card is not seen. लैब कार्ड, लैब कार्ड क्या है भाई? क्षितिज भाई लैब कार्ड क्या है? कॉल कर रहे हैं? Wait a second. Let me mute.